So this video is going to go over the problem set questions that we had assigned to us for lesson 11 in our Eureka packet. And I wanted to just take a moment and go through these with you since some of you may not be in class, or if it's on Wednesday, I'm not going to be here either. So I just want to make sure that we're able to go through them and you can see how they're solved. That way it alleviates any questions. If you have further questions, obviously, feel free to reach out to me or hold on to them. And when we see each other again, we can go over those together. So let's get on to this. The first thing is the problem set question number 1. It reads, there are approximately 7.5 times 10 to the 18th grains of sand on Earth. There are approximately 7 times 10 to the 27th power atoms in an average human body. So the first question is asking us, are there more grains of sand on Earth or atoms in an average human body? And how do we know? So the first thing we have to look at here is this whole idea of what are we actually looking for, right? So when we're looking at comparing, because we want to know just how many more are there. So for the grains of sand, we're looking at this front number usually. And for the human body, we would be looking at this number. But see, it's a little bit misleading because if we just look at that coefficient or that front D value, 7.5 appears to be larger than 7. However, we have to remember that when we're dealing with scientific notation, this second value, this 10 to the 18th and 10 to the 27th power, those are showing how the size or the magnitude of this number. So remember, the 7.5 times 10 to the 18th would mean that we have a 7, and then we have our decimal that's going to move 18 spaces to the right. So it'd be 7, and then we'd have a 5, and then we'd have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 zeros. Now, the difference is for the human body, the atoms in a human body means we're going to have a 7. And then we're going to put 27 more place values to the right. So that means that we're going to have our 7, and then we're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27 zeros. Oh my goodness, that is a huge number. So from that, we have to ask ourselves, which one is greater? And the answer is obvious. It's the amount of atoms in the average human body, because 7 times 10 to the 27th power is a much larger number than 7.5 times 10 to the 18th. So with number 1, they want us to understand this idea that we can't just look at the front number. We have to actually look at the whole number, most especially that power of 10. If the power of 10 is larger, then the number is just going to be larger. Now, if the power of 10 was the same, then we would look at the coefficient value to find the larger number. So in this case, number 1, the answer should be that there are more atoms in the average human body. And our reason for how do we know? The power of 10 is much, much larger. Now let's go to question number 2. They're asking us now, how many times more atoms are in the human body compared to grains of sand on Earth? So for this problem, what we're going to do is we're going to create a ratio. So we want to know how many times more atoms in the human body, which means we're going to put the number of atoms in the human body, which is 7 times 10 to the 27th power, over top of 7.5 times 10 to the 18th power. And since we're just looking for how many more times, we're going to actually do the division problem. And if you remember, we're able to split this problem into 2 different parts. We're able to divide the powers of 10 separately from the coefficients. So let's start with the coefficients. The coefficients are just a simple problem, 7 divided by 7.5. Now, if I punch that into a calculator, I get a decimal, and I'm going to get 0.93 repeating. And I know that this is going to be multiplied by 10 to a power. Now, to find this power, if you remember, our rule is that if we're dividing powers that have the same base, we subtract their exponential value. So really, we're looking at 10 to the 27 minus 28, which is ninth power. So this should read 0.93 repeating times 10 to the ninth power. Now we have a little bit of a problem because this can't just be a decimal. So what we want to do is we want to convert this. So I'm going to move my decimal one space to the right. And when I do that, all right, I'm making this number larger. So that means that my power of 10 is being reduced by 1. So this is going to become 9.3. Now 9.3, I'm just going to estimate here, 9.3. And I'm allowed to do that because it said about how many times. So it's 9.3 times 10 to the 8th power. And that is how many times more atoms are in the human body than grains of sand on Earth. Amazing. Now, from here, all right, let's go to question number 3. So I'm going to scroll down here to question number 3. And question number 3 is asking us to suppose the geographic areas of California and the United States are 1.637 times 10 to the 5th power and 3.794 times 10 to the 6th power square miles, respectively, obviously. California's population, using a 2012 value, is approximately 3.804 times 10 to the 7th people. So what they're saying is that if population were proportional to area, what would be the United States population? Now, when we're talking about proportions, let's take a look at this. What we're doing is we're going to compare the values. So we're going to compare the area, and I'm just going to put area of California over the population of California. And we're going to say that that is proportionally equal. That ratio is going to be equal to the area of the United States, or United States of America, we'll put USA, and its population. So to make this true, we're going to plug in the values, okay? So the area of California is going to be 1. Now, some people could say that we could estimate this, right? So we could say that this is like 1.6 times 10 to the 5th, but we're going to write it all out here. So it's going to be 1.637 times 10 to the 5th power over its population, which is 3.804 times 10 to the 7th power. And that has to be equal to the area of the United States, which is given to us as 3.794 times 10 to the 6th power, over top of the United States population, which we don't know. Now, I really probably should not use, let's see here. Well, I'll leave it. I shouldn't use X, but I'm going to. That's okay. I'm not worried about it right now. So in order to solve a proportion, we start with our variable, and we're going to grab the number on top, cross, multiply, and divide. So what I want to do is I want to do a multiplication problem here. So I'm going to multiply 3.794. So 3, I'm putting it on a calculator, 3.794. And I'm going to multiply that by 3.804. And I end up with 14. So let's do this, 14.43. Now I'm going to stop there. And if I multiply their powers, 10 to the 6th times 10 to the 7th becomes 10 to the 13th power. But I still have to divide this. And I have to divide this by 1.637 times 10 to the 5th power. And you might be asking, Mr. Blows, why didn't you convert this top number into scientific notation? Remember my rule. I don't convert anything into scientific notation until I'm done. Because when I divide, there's a good chance that it's going to drop below a double-digit number. So I want to make sure that I'm not just doing extra work. Now, when we divide, remember, we're going to convert this into two different problems. So really, I'm getting 14.43 divided by 1.637. And for that, I get 8.81. So we're going to say that this is going to be 8.81. Notice it's now back to a single digit, times 10 to the power of. Now, when I'm dividing, 10 to the 13th divided by 10 to the 5th, 13 minus 5 is 8. So it's times 10 to the 8th power. And that's going to equal the population of the United States. So if we're looking at this, all right, this population of the United States, let's convert this into a number here. So we would have an 8, and then we'd have to move this decimal, all right, 8 place values. So 8 is 1, 1 is 2, 3, 4, 5, 6, 7, 8. So we would have approximately 881 million people living in the United States, according to this calculation. Okay, so again, that was question number three, and we are calculating this to be 881 million people. I should probably put in people here. Living in the United States of America. All right, so a pretty cool calculation as far as using a proportion. And remember, we set this up comparing the area of California and the population of California to the area of the United States and the population of the United States. Okay, now to question number 4. The actual population of the U.S. is approximately 3.14 times 10 to the 8th. Wow, so we were kind of close. We weren't exactly close, but we were kind of close. They want to know, how does the population density of California, in other words, the number of people per square mile, compare with the population density of the United States? Oof, this is a tough one now. All right, so what this means is we have to take the number of people per square mile. So number of people in California, we're going to take that population. So the population of California is 3.804 times 10 to the 7th. So we're going to set this up as 3.804 times 10 to the 7th people. And we're going to divide that by its square area. So the area of California is 1.637 times 10 to the 5th. So 1.637 times 10 to the 5th. Okay, so again, we can divide this very simply. So we're going to take 3.804. We're going to divide that by 1.637. And I get 2.32. So I'm going to do a little estimation here. So 2.32 times 10 to the 7 minus 5 is second power. Okay, now again, this is the population density of California. So this is California. I'm going to put a CA there. Now I have to do the same thing for the United States. So the United States is 3.14. Reminds me of pie. Now I'm hungry for pie. And that's the population of the United States divided by its square area. And the square area of the United States is 3.794 times 10 to the 6th. So 3.794 times 10 to the 6th. And we're going to divide that out. So 3.14 divided by 3.794 is 0.827, or 828 actually, times 10 to the 2nd. Now, this is not in scientific notation, so I have to move this. All right, so I'm going to have to move one decimal here to make that larger, so this has to get a little bit smaller, which means it's going to be 8.28 times 10 to the 1st power. And this is the U.S. So those are the two population densities. Now, what they want me to do, sorry, got a little tongue tied there, is they actually want me to compare these. They want me to compare these. So the density, and if I put this into a real number here, all right, 2.32 times 10 to the second power is actually 232 people per square mile. And the United States total is just going to be 82.8 people per square mile. So it's more, the population density of California is greater. Okay. Now, if we wanted to go a step further and find out how much greater, we would divide these. So if I just divide these together, 232 divided by 82.8, I get 2.8. So we could say that the population density of California is 2.8 times greater. Or we could say that it is 2.8 times more dense than the United States. So if you are an individual who's looking for some land and you want to have, no, you don't want to have a whole lot of people living near you, probably don't want to live in California, right? You're going to want to live somewhere else because it's going to be more dense per capita than anywhere else. Okay. So again, just wanted to go through lesson 11 with you, and that's the problem set and the explanation. Hopefully it helped you out. Hopefully it answered some questions. Obviously, if you're off a little bit because of rounding of decimals, we're not too worried about that. However, if there are major questions, we should probably address those when I see you next time. Have a great day, guys.